uh, we have done one example and now we have to do two more examples, and then we will wind up the lecture. Okay, so the second example is d is equal to um, x cube ax plus this is this, okay? This in RCS. Okay, so but now the problem is we have given the surface of the cylinder. So we will convert this d into CCS whenever we need it. Okay, uh, in the Z component we doesn't need to convert it into the CCS, because the Z of the RCS is the same as the Z of the CCS. Okay, so here almost the same example, but it is quite simpler than the previous one, because we have the full cylinder. Okay, so the limits of the full cylinder will be applied, and secondly we have the same Z from 0 to Z is equal to 2, and the same x square plus y square is equal to 16. It means that rho will be equal to 4. Okay, we have to apply uh, the square root, so rho will be equal to 4 meter. And the same question we have to prove the divergence theorem, means we have to find the psi for this, and then we have to find psi for this, then we will equate these two, and will compare that whether the answer of the both will be same or not. Okay, so uh, let's have a look. First we have to solve this divergence, this del operator. So del operator for RCS is this partial or partial x of x cube. Okay, x cube is given, and then partial over partial y of x square y, and partial over partial z of x square z. So we will get 3x from here. Okay, 2x from here, because no the divergence of y is 1. Sorry, x square, because x will be constant for this, so it will be moved over here. So partial over partial y of y will be equal to 1, and we will left with x square only. So partial, again the x square will be moved outside the partial, because it will act as the constant for the z. So x square partial z of z. Okay, so we will have this. Then we have to psi, we have to apply the integration in RCS. The limits for the Z are 0 to 2, are 0 to 4, and 5. For the full cylinder, we have 0 to 2 pi. In the previous example, we have the quartered cylinder, so in that case, 5 was 0 to pi by 2, but in this case, we have the full cylinder. So this example is looks simpler than the previous one. Okay, so apply the integration. So we will get this 5 into 10 is 5 into 32 into 2 pi. So this is equal to 2010.62 coulombs. So this is the answer from the left side, del dot d. Okay, now we have to apply the second portion of the divergence theorem, that is the surfaces, using the surfaces. So in this case we have the simple structure. So this this and this. Okay, so we have only uh, this surface, the top, which is in the direction of plus z, or we can say that it is in the z is equal to 2 plane. Z is equal to 2 plane, or we can say it is in the direction of plus z. Okay, this is in z is equal to 0 plane. Okay, or we can say that it is in the direction of minus z. And the third surface is this curvy surface, which is in the direction of arrow. So we have only these three surfaces. So that is why it is very simple, simpler than the previous one. Okay. So now closed surface for D dot ds, this is one, two, and three, only three surfaces. The one surface is in the direction of rho, which is that curvy surface. Okay. The second is in the direction of plus z, which is the top of the cylinder, and this third surface is in the direction of z minus, means in the bottom base of the cylinder. Okay. So consider the cylindrical surface in the D. First we will solve this. Okay. Then we will solve this and that. Okay. So now D in CCS, because the D, we have given the D in RCS, but now for the S row, we must have to convert this D into CCS. Okay, so that is the formula for the conversion. Cos phi sin phi 0, this is the dx dy dz. So instead of dx, we will put the x component of the d, that is x cube, given dy given here. Look, this is dx dy and dz. Okay, given. So x cube, x square y, x square z. Okay, so now as we have the limit for the rho, phi, and z, so replace x is equal to r cos phi, y is equal to r sin phi, z is equal to z. So we will get this rho cube, cos cube phi, and this and that. Okay, so rho is equal to this d d rho d rho. Okay, so d dot ds rho, that will be equal to the a row component of the d only will be used. Okay, the row component, this d row, the row component of the d will be used. So that is why we have rho cube cos square phi, rho cube cos square phi, only this one. Okay, this is the d row component, and this is the ds for in the direction of rho. So rho d phi dz. So we multiplying by multiplying this, we will get this. Okay. So psi, in order to find the psi, putting the limits 0 to 2, 0 to 2 is the limits for dz, and 0 to 2 pi is the limits for d phi. So we will get psi 1 1608 point this. Okay, now at z is equal to 0 plane, means this base, okay, and this is in z is equal to 0 plane, so we have to put the value z is equal to 0 in the variable, and the direction for this base is in minus z. Okay, so az and minus, means minus az. Okay, so the ds in the direction of minus z will be equal to minus rho d phi. Okay, and this is in the direction of minus az. Very simple. Okay, so replace x is equal to rho cos phi. So d dot ds, only the z component will be used now. Okay, so x square z, this is the z component of, means dz. Okay, so where is dz? This one. Okay, we will use only this portion, because when we will apply the dot product az with the az portion of the ds, so we will get 1 from this one, and if we multiply ds portion with this dy and dx, so these will be equal to 0 because of the dot product. So only the d z portion of the d will be used. Okay. Okay, so the dz portion is which one? x square z. Okay, so replace x is equal to rho cos phi, so this will be equal to minus this. Okay, and this rho will be multiplied with this rho square, so we will get minus rho cube. Okay, as it is in the z is equal to 0 plane, so replace z is equal to 0. Okay, this will be equal to 0. So the whole equation will be equal to 0, because 0 multiplied by cos square phi multiplied by this, all the values will be equal to 0. Okay, now consider the uh, cylinder z is equal to 2. Z is equal to 2. So z is equal to 2 plane means this, the top one. Okay, in the direction of plus az. So this is in the direction of plus az, so that is why we have used the plus az. Okay, okay, so the surface in the direction of az, rho d phi, no z will be involved in this. Okay, so d dot ds, the dot product, so the dot product will be this. Okay, we will use the z portion only, as we have used over here x square z. So replace this by this, so the same ds, but we have the difference of only minus. Okay, in this we have no minus. And secondly, as we put z is equal to 0 over there, but now we have to put z is equal to 2. Okay, so the solution will be non-zero because of z is equal to 2. So we will get psi 3 like this. Now adding, by adding all the three size, uh, so we will get 2010.62, means 11608.0 plus 0 plus 402 point this. After adding these three, we will get this, which is equal to the previous result of this d dot d. So hence the divergence theorem is proved. Okay, okay, now the similar example, but now in the spherical coordinate system. Okay, and in spherical coordinate system, the complete sphere is not given, only a small portion of the sphere is given, and we have the limits for this portion of sphere are from 0 to from 1 to 2, and theta from 0 to pi by 2, and the phi 0 to pi by 2. Okay, and the d is given this one. And in d we have ar portion, means the r portion in the direction of ar, and the theta portion, and we have no plus 0, we have 0 a5 portion, no a5 portion. So whenever we have the we need the a5 portion, so it will be 0. Okay, so again we have to prove the divergence theorem, this and this. Okay, so we will start with the del operator. So the del operator for the spherical coordinate system is 1 over r square. We have already studied these in the previous lectures. 1 over r square partial over partial ar. This. So this is actually the del dot d for spherical coordinate system. Okay, here d phi is equal to 0, so this portion will be equal to 0. We have no d phi. Okay, so we will left with only these two. So now uh, apply. Okay, this minus 2 cos theta over r raised to the power 4 plus 2 cos theta r raised to the power 4. So these two are equal and opposite in sign, so these will be cancelled out, and we will have the value operator del d is equal to 0. Okay, now the right hand side, that is the surface, the surfaces So the ds surface, the dr surface, okay, and dr minus, okay, for each portion, for r is equal to 1, that is the separate surface. For r is equal to 2, that is the separate surface. For theta is 0, no surface will be used, because theta for 0, that will be equal to 0. So theta pi by 2 surface, pi pi by 2 surface, okay. So for each limit we have to take the separate surface, separate plane. So now this is the r is equal to 2 plane. So so the surface for in the direction of AR is r square sine theta theta. This is the differential surface in the direction of AR. Okay, we have already studied in the previous lectures. So we will get this. The R portion of the D will be used only. This is the R portion of the D. R square, sorry, this 2 cos theta over R cube. Okay, only the R portion. Here is the this one is R portion, 2 cos theta over R. This will not be used, because later on by applying the dot product this will be equal to 0. So no need to take this. Okay, so this is the R portion of the D. Multiplying these two, we will get this. As R is equal to 2, replace R by 2. So this will be equal to 2. 2 will be cancelled out with this 2. So sine 2, no, sorry, sine 2 theta theta d phi over 2. Okay. Okay. So taking it outside 1 over 2 and applying the limits for the phi, which is from 0 to 2, pi by 2, and the limits for theta is also from 0 to pi by 2. So replace these two and applying the integration, we will get pi by 4. Okay. Now the minus r direction. Okay. So we will have minus 2 sine theta cos d theta d phi cos theta. Okay. Only the r portion will be used. So we will get this. Okay. Sine 2 theta and d theta. This is actually the formula. Okay, 2 sine theta d theta, this is equal to sine 2 theta. Okay, sine 2 theta is equal to 2 sine theta cos theta. Okay. So trigonometric formula. So applying this, because this will reduce your function, sine 2 theta, sine 2 theta integration is minus cos 2 theta over 2. So putting the limits 0 to 2 pi, and in the phi 0 to 2, 0 to pi by 2, 0 to pi by 2, we will get this minus pi by 2. Okay, now d phi 0 limit. Okay, so all this will be equal to 0, so no need to take this. Now a theta, a theta, there is no phi portion, there is no d phi portion. As I have told you in advance, that there is no d phi portion. So for this, no need to find the phi, the phi plane. Okay. Okay. So now we will switch to theta, the theta surface. Okay. So d dot ds theta. Okay. So only we will use the theta portion of the d. Here is the theta portion of the d. Okay, sine theta over r cube. Okay, so sine theta over r cube. This is the d portion, theta portion of the d, and this is the surface, d surface in the direction of d theta. This is the d surface, partial surface in the direction of theta, which we have already studied in the previous lectures. Okay, all the differential surfaces are studied in the previous lectures. Okay, all the ds, all the dv's, okay, and all the dl's in RCS, in CCS, in SCS. All these three are studied. Okay, and each portion ds in the direction of x, in the direction of y, in the direction of s. So similarly, this is in the direction of a theta. So a theta, ds in the direction of a theta is r sine theta, dr d phi. Okay, so multiplying these two, we will get this sine square theta over r square, applying the limits r from 0 1 to 2, and for theta 0 to pi by 2. So we will get this one. Okay, so after adding this plus this plus this plus this, we will get the answer. We will get the answer. Okay, this is pi by 4 minus pi by 2 plus 0 plus 0. So we will get what? Okay, this is again pi by 4. Okay, so pi by 4 plus pi by 4, this is pi by 2, and minus pi by 2 is equal to 0. So the similar results are obtained from this is also equal to 0, and this was also equal to 0. So means the divergence theorem has been proved. Okay, that is all for the moment.